Imagine a universe where conditions are just right, not too hot, not too cold, but perfect for life to flourish. Like the porridge in the tale of Goldilocks, certain cosmic conditions need to be just right for life to exist. This principle, aptly named after the curious little girl, is the key to understanding where we might find life beyond Earth. It's all about finding that sweet spot, that perfect balance. This is the Goldilocks Zone, a habitable region in space where life as we know it could potentially exist. Life as we know it hinges on one main component: water. Water in its liquid form is a fundamental ingredient for life. It's the solvent that facilitates chemical reactions within living organisms, the medium that enables cells to transport nutrients and waste, and the substance that regulates temperature in living organisms. It's the lifeblood of biological processes on Earth, and scientists believe it could also be the key to finding life elsewhere in the universe. So, what makes a zone habitable? The answer lies in the delicate balance that allows liquid water to exist. A habitable zone, also known as a Goldilocks zone, is determined by a planet's distance from its star. This distance is crucial because it influences the planet's surface temperature, which in turn determines whether water can exist in liquid form. Imagine a planet too close to its star. The intense heat would cause any water to evaporate, creating a world of perpetual steam. On the other hand, a planet too far from its star would be too cold, and any water would freeze, creating a world of perpetual ice. But a planet in the Goldilocks zone? That's just right. The distance from the star is neither too close nor too far, leading to a surface temperature that allows water to exist in a liquid state. It's a zone that's not too hot, not too cold, but just right for liquid water, and therefore, just right for life as we know it. Of course, being in the habitable zone doesn't guarantee the presence of life. There are other factors in play, like the planet's atmosphere, its geological activity, and the presence of a magnetic field to protect it from harmful solar radiation. But the presence of liquid water is a promising start. In essence, a habitable zone is a region where a planet is neither too close nor too far from its star, allowing liquid water to exist. It's where the magic of life has the best chance to unfold, where the cosmic dance of star and planet might just give rise to the extraordinary phenomenon we call life. Our very own solar system has its own Goldilocks zone. It's a region where the conditions are just right for life as we know it to exist. Not too hot, not too cold, but just right. And guess what? The third rock from the sun, our Earth, is smack dab in the middle of it. Earth's placement within this zone is no accident. It's at just the right distance from our star, the sun, to maintain an average temperature that allows water to exist in its liquid form. And where there's water, there's the potential for life. The Earth's atmosphere, a delicate mix of nitrogen, oxygen, and a smattering of other gases, acts like a blanket, trapping just enough of the sun's heat to keep us warm, but not too warm. This balance, this equilibrium, is what makes Earth a haven for life. But it's not just about temperature and water. Earth also possesses a magnetic field, a sort of protective shield that deflects harmful solar radiation. Without it, life as we know it would be hard-pressed to survive. And let's not forget the importance of having a stable orbit. Earth's path around the sun is nearly circular, which means the amount of sunlight we receive doesn't vary drastically throughout the year. This stability in sunlight allows for the change of seasons, providing a rhythm of life that many organisms, including humans, have adapted to. On top of all that, Earth's tilt on its axis gives us our seasons, a cyclical change that drives the ebb and flow of life across our planet. From the blooming of flowers in spring to the hibernation of animals in winter, the tilt plays a crucial role in the diversity of life on Earth. All these conditions, and probably more we are yet to understand, come together in a perfect balance to make Earth the thriving, life-supporting planet it is. So, here we are, on a blue marble floating in the vast expanse of space, perfectly positioned in our solar system's Goldilocks zone. Earth, with its perfect balance of conditions, sits comfortably within our solar system's Goldilocks zone. Our search for life in the universe isn't confined to our solar system. This statement should come as no surprise, given our innate curiosity and drive to explore the cosmos. In our quest to find life, or at least the conditions suitable for it, we've extended our gaze far beyond our own celestial neighborhood. But how exactly do we find these potential havens of life, these Goldilocks zones, in the vastness of space? The answer lies in the impressive advancements in technology that have allowed us to locate exoplanets within their star's Goldilocks zone. Scientists use a method known as the transit method. This technique involves observing the dimming of a star's light as a planet passes in front of it. By measuring this dimming and the time it takes for the planet to orbit its star, scientists can determine the planet's size, its distance from the star, and consequently, whether it lies within the star's habitable zone. The Kepler Space Telescope has been instrumental in this endeavor, discovering thousands of exoplanets since its launch in 2009. Among its most notable finds are Kepler 22b and Kepler 186f. Kepler 22b, discovered in 2011, is situated about 600 light-years away from us. It orbits a star similar to our Sun and is located within its star's Goldilocks Zone. While it's about 2.5 times the size of Earth, much remains unknown about its composition and atmosphere. Kepler 186f, found in 2014, is even more exciting. It's the first Earth-sized planet discovered in the habitable zone of its star. Located about 500 light-years away, it provides an enticing hint of the possibility of Earth-like conditions elsewhere in the universe. The discovery of these exoplanets is a promising step in our quest to locate other habitable zones in the universe. These advancements in technology and successful discoveries fuel our optimism and determination as we continue to reach out into the cosmos, searching for our cosmic neighbors in the vast expanse of the universe. The search for other habitable zones is far from over. As we look towards the future, we find ourselves on the brink of a new era in space exploration. The journey to understand Goldilocks zones is intrinsically tied to our pursuit of advanced technologies and innovative scientific missions. In the coming years, we can expect a flurry of activity as space agencies around the globe prepare to launch missions aimed at discovering more about these habitable zones. NASA's James Webb Space Telescope, set to launch soon, will allow us to peek into the atmospheres of exoplanets residing in their star's Goldilocks zone. With its unprecedented sensitivity, we'll be able to detect potential signs of life, like water vapor and certain gases, that could hint at the existence of biological activity. And it's not just NASA. The European Space Agency's Plato mission will also focus on finding and studying a large number of extrasolar planetary systems, with an emphasis on those in the habitable zones of their parent stars. In addition to these missions, technological advancements are also playing a pivotal role. As we refine our capabilities in detecting exoplanets and analyzing their atmospheres, the chances of finding a world with conditions similar to Earth increase exponentially. Imagine the possibilities that lie ahead with the development of larger, more powerful telescopes and more sensitive spectrographs. Yet, it's not just about finding these zones, it's about understanding them. The more we learn about these habitable zones, the closer we get to answering one of humanity's most profound questions. Are we alone in the universe? The universe is vast, and our search for other Goldilocks zones is just the beginning. As we continue to unravel the mysteries of these celestial neighborhoods, we edge closer to potentially discovering life beyond our own planet. And who knows? Maybe one day we'll find another world out there in the cosmos that's just right for life as we know it.